YouTube off. Oh, nobody gonna turn it up. Take your headphones off. Close your computers. Let's close them computers. Daniel, your pencil. I'm gonna get it for you. I'm gonna get your pencil for you. Where you go? Still doing it at a level 0 though. How you guys feel about this non-academic do now? Just something to get you in the mood of coming into science class. You guys like that?
Yes, we do it every day.
We should do it every day.
Yes, it makes us
Why is he recording us?
We should do it every day. He's not recording you. He's recording me. You want to know why he's recording me?
So it can make you
Because
TikTok
I'm
famous.
special.
So it can make you TikTok famous.
Because I'm cool, man. You guys are good.
So you can maybe TikTok famous.
You can notice how good you
Oh,
about that.
I am not paying any of these kids to say that.
Yeah, he is.
So guess what we get to do next? We have a learning target. Ooh. Go ahead, Aubrey. It's over here though. It's not on there because you're supposed to close those. It's right here. It's real small.
I can find Newton's second law of motion.
Remember we went over the first law of motion? Anybody? Anybody remember the first law?
Yeah.
Ariel. Ariel, what's the first law of motion? You can use your notebook if you want to. What am I doing right now?
Staying still.
Standing still, which also means I'm what?
You're
At
rest.
I'm at rest. So when can I move?
When you're not at rest.
When I'm not at rest. But what's going to move me?
Force.
Force is going to move me. Perfect. Force is going to move me. Dude, you know you're on film, and that's assault. So, what's up, Aubrey? Hey, Aubrey, how you doing? What's up, Aubrey? Motion by an external force? London.
We put in motion.
Put in motion by an external force. London. What you got?
I have to go.
Say it. Yeah,
I
go.
said the first law is.
Speak your mind.
I know what it is. Don't tell me.
I need you to speak your mind 5 minutes ago.
An object on motion will stay at motion unless given a. An object at rest will stay at rest unless given something a force.
You know what? I am happy you know that much of it. And you remembered that much of it. Ryan, help her out.
An object not restful or may not rest unless a non-zero net force is acted upon it.
That was not what you said.
Say that again?
That's not what you said.
What? He just said
No,
it.
you said that an
No,
object at rest and an object
You
at
missed all of it.
Will stay in those states unless
given, unless
After
Force is
something
applied.
by force.
Unbalanced
Unless
force.
the unbalanced force is
Unbalanced
applied.
force.
They're both.
Brando, you want to add to this conversation?
An object at rest will remain at rest unless moved by an unbalanced object.
Moved by an object at rest. So same thing applies to an object in motion though, right? So this is going to bring me to some 3 most important questions as we get into Newton's second law. Do you know what Newton's first law is? Sam.
An object at rest will stay in rest. An object in motion will stay in motion at a constant velocity unless an outside force acts upon it.
Okay, so Malcolm, what's an outside force that would cause whatever's in motion to not be in motion? I'll do me a favor, bud. Sit down. Sit down. I can't hear myself. You didn't hear what Samantha said? Did you hear what Brando said? Did you hear what Ryan said? Did you hear what London said? And what Aubrey said? And what Ariel said? And what Daniel was about to say right now? What you got? A magnetic force? What was the question? What was the question? Remember the question? I don't remember the question either. But Daniel said a magnetic force can move something. Is that true or false?
True.
DeMar, is that true or false? It is actually true. A magnetic force can move something. What can it move?
Another magnet.
It can move
Opposite
it can move another magnet.
I mean, the same force.
So let me ask you this though. I'm gonna ask LaShawn this question, and Isaiah can help you out. If I have a magnet and I have a North Pole and a North Pole, how do they move? And what kind of force is that? Do we call that a contact force or a non-contact force? And why would they move together or move apart?
They would move apart because there is two north sides trying to touch each other. It could be only north and south or south and north. Reason for it because the poles are like the same amount, so it would like bounce off of each other, and then maybe because like the poles are the stronger part and the middle is the weaker part.
Okay, so what kind of force do we call that? Is that a contact or non-contact? If you have
Non-contact.
non-contact, if you have north and north, because from what LaShawn's explaining is that if you have two like poles, they repel. Next question is, can you explain real world examples of Newton's first law? Right now, Monte's at rest. What moved you? Force. The force. Like I'm a Jedi and I was like that, and you got up. Ryan.
So this pencil, it stands at rest, but if I threw it at your head, it would not be at rest because in our hand it was an external force.
Why would you want to throw a pencil at my head?
It was an example.
It's just, why would you want an example of throwing a pencil at my head?
It's kind of like how I use
To show it will
Oh
never
my
happen.
gosh.
To show it won't happen because it's just an example.
So let me ask you this. Let me ask you this. This is a real world example right here. If I throw knowledge at your head, what's gonna happen?
You're gonna learn.
You're gonna learn?
You're just smarter.
You're gonna get smarter?
No.
Is that contact force or non-contact force?
Non-contact. Non-contact.
Non-contact
Because like
force.
learning by like teaching them in here.
So while we're on force, the third question, do you recall what force is? What's force? What's force? Leandre, what's force? It's a push or pull. So if it's a push or pull, how can I throw knowledge at you and I'm using force? Am I literally throwing a book at your head and say, learn this?
Yeah.
No? Who said yes?
You can have.
I'm throwing a book at you? I must have threw an encyclopedia at you because you're kind of smart.
It'll make us learn
The duck? Yeah, you'll learn something. That's called a reaction.
You're gonna learn.
Wow, what is that? Okay, so when we talk about Newton's second law, I know about a month ago I went over the second law with you guys and you girls. Who recalls the second law?
I don't.
Who said ooh? Take a shot at it. You don't know?
I just said I need one.
You need your notes. I'm glad you got your notes. I'm reading it right here with this book that I picked up using the force.
Mr. Williams, Mr. Dunker, may I put this on your door, please? Thank you.
Oh man. Ms. Strader, you know my rule? I'm getting filmed right now.
I'm so
So
sorry.
because you interrupted, you have to introduce yourself.
Yes.
Oh, I'm Miss Strader. Hi, I'm the prevention specialist. Sorry for interrupting. But
It has something to do with the law. It has something to do with motion. And it has something to do with force. And it has something to do with mass. It has something to do with acceleration.
Explain how force in mass determine an object's acceleration.
How force and mass determines an object's acceleration. Who remembers what acceleration is? Brando, you're itching to talk, dude. You're itching for it. What's acceleration?
So that gives like define it, or can I
You can define it.
can I do like an example?
Sure. I'll give you a good example. Damar's mouth is moving from 0 to 60 in 2 seconds. Is that acceleration?
Yes.
Okay. So give me your definition and you give me an example.
So a definition is kind of whenever there's a change in speed, I think, like if this pencil's like moving
something changed. Brando said something changed. And he also brought up velocity.
It's the rate of velocity.
It's the rate of velocity?
Yeah, like it's like how velocity changes and like increases or decreases.
There you go. Change in velocity. It's a rate of change in velocity. Who remembers the formula? I'll give you bonus points. If you, Leandre, what's the formula for velocity? You don't know? Sam, what is it?
Acceleration equals initial velocity minus final velocity divided by time.
Do you remember what the SI units are?
Oh,
Ryan, what's the SI unit?
meters per second squared or meters per second per second.
Meters per second. Mr. D, is he correct?
I'm sorry,
SI units
for acceleration,
for acceleration.
meters per second, or
Or
Meters per second squared, I said that too.
Was I right?
so what we're going to do now is when we talk about Newton's second law, he is talking about force, mass, and acceleration. What's mass?
Mass is the weight of you.
Is it really?
It's like,
Is it really
it's like your body. It's like
the stuff in your body? What do we call the stuff in your body?
your cells.
Cells? It starts with an M. Come on, people.
You're materialistic in.
It's not materialistic in.
Matter.
Matter.
My matter.
You do matter. London matters. Good vacation spot. London matters. So when we talk about mass, we're talking about not exactly weight, but matter of which we are made up of. Now, what's the difference between mass and weight? Sure, there you go. Look at that. Following the rules. Go ahead, Aubrey.
Mass, like anywhere you go, like we turn on like planets, your mass is the same but your weight. You need to go. Your mass is the same wherever you go, but your weight.
So she said your mass is the same wherever you go. Isaiah, you agree with that? Your mass is the same no matter where you go. Your weight will change. What's up, Ryan?
Mass is basically like a permanent weight. Like it's how much stuff is inside of you. And to get weight, you have to do mass times gravitational force.
Was he right? To get mass?
Mass times mass times gravitational force is weight.
Mr. Dunker, do you agree with that? Mass times gravitational force is weight? Oh, we got a winner. Good. Good job, Ryan. Okay, so force. Newton's second law, force. How do we calculate force? Aubrey-on, how do we calculate force? You answer this correctly. What's the formula? If you answer this correctly, you can go to the bathroom. What's the formula for force? What do you think the formula for force is?
Girl, if you don't look on your board.
What?
She's trying to help you.
Girl,
So what do you have? What's the formula for force? What is it? You said you can't see it? Did you say? Because I didn't hear you. Did you say you can't see it on the board?
Read the board, the rest
Acceleration.
Oh my gosh.
Hold on. So force equals what? What's the M stand for? What's the M? It's not motion. Because remember we said that force deals with mass and acceleration. So what do you think the M stands for? What do you think the M stands for? Mass. So get this one and you'll be on your way. What's the A stand for? As I accelerate to the front of the room.
Say it. Talk it.
Acceleration, you earned your trip to the bathroom. Force equals mass times acceleration. Mass times acceleration. You earned your trip to the bathroom.
Go to the bathroom.
You either gonna go or you're not gonna go. You can pass the baton. Pass the baton.
Why y'all keep telling me?
Why y'all keep telling her to go?
Because you just said
It's okay.
Let's go to the bathroom.
3, 2, 1. Back on me. Mask, 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 mask. Force is motion times acceleration. I know we remember this. So I need one example. One example. And let's deal with a shopping cart. Because I heard this one earlier today and I thought it was pretty good. You ever push a shopping cart?
Yeah.
When it's empty?
Yeah.
Did you ever like push it and like stand on it and start rolling down there? Yeah.
Wait.
Now hold on. Remember we talked about momentum and inertia?
Yeah.
So what happens when that shopping cart is full? Is it easy to push?
No.
So we have to use more what for it to go? More force for it to go. So if we use a whole bunch of force and we jump on it and start rolling, what happens?
You're gonna fall back. It's gonna tip back because of your weight. Your mass inside your body.
But it's full of food.
I know, but it's
Yeah,
still back.
but
The
what
food
you-
is
but
not
what you-
heavier than a
So
person.
hold on. So what if the food weighs more?
Then
Then it's going to stay on the ground.
It's going to stay on the
But
ground.
it's not gonna roll as
But
much.
why would it stay on the ground?
Because of its mass.
Because it weighs more. It'll stay on the ground.
And because it has more acceleration.
But hold on. Okay, so hold on. So more acceleration. So one question we had earlier was, do we remember what we did last week?
Ooh.
What did we do last week? Was you here last week?
Oh, we did
I
tug
kind
of
of
war.
wasn't. We did tug of war.
Yeah, we was tearing y'all.
Why was we
up.
doing tug of war? Oh, whoa. This isn't the bragging session. So what happened in tug of war? Why did one team win over the other, Aubrey?
Because that's
Hold on, London. I appreciate the enthusiasm and you're shouting out right answers, but at the same time, I don't mind the shout out. But when someone raises their hand and I call on them, let's give them a turn.
So, because basically,
Thank you. Appreciate
when
that.
our
Go ahead.
team, we had more force that we were pulling and the other team didn't. So since they had less force, we were stronger, so we pulled them over.
So you pulled them, but what kind of force was that? Was it balanced force or an unbalanced force?
Unbalanced.
It was unbalanced.
Because
Okay, so here we go again. Well, I'm on my shopping cart. There's more mass, there's more weight in the shopping cart. I'm pushing with more force now. And I jump on it. And because of inertia, what happens?
stop. No, wait. Is there stuff in the shopping cart?
you go forward.
Well, here's the thing though. I'm pushing it. So my acceleration is moving. So let's say I'm accelerating at a rate of what? 10 meters per second? 10 meters per second?
60.
And with my weight, because I don't weigh a lot, and the food, let's just say that's 100. 100, let's say 100 kilograms. And I'm moving at 10 meters per second. How much force is being applied? Because Aubrey-On just gave us the formula.
16 meters, 16.
Where are you getting 16?
That's
The
the number.
speed,
The
my
speed,
velocity,
yeah, your velocity.
10 meters per second. The mass, the combined mass is 100 kilograms. Ryan,
Can I give an example of an equation?
I would not want you to give me an example of an equation. However, I do want you to answer the question.
Wait, what are
What's the force?
Wait, what are the numbers again?
10 meters per second is my acceleration.
And what's your mass?
My mass, combined mass with me and the food is 100 kilograms.
Okay, so you would have to multiply them. So 100 kilograms times 10 meters per second squared would be 1,000 newtons.
1,000, what's a newton?
The SI unit of force.
The SI unit of force is a newton. Ariel, you agree with that? Because he said that with confidence. He said it with so much confidence that the SI unit for force is a Newton. You agree with that? You do? When you shake, when your head is down and you shake it that way, it looks like you're saying no. Thumbs up. I got a thumbs up. Leandre, what do you think? What did the back of your eyelids tell you?
Sleep.
Did it tell you that Ryan was correct saying that the SI unit for force was a Newton? Oh man, you're on point. So I'm good. That's all I have.